My name is Andrew. I go to Millard West. I did my internship through Intern Omaha at E&A Consulting.
My name is James. I go to Millard West. I did my internship at Kiewit Building Group. We had a capstone class called STEM, STEM design, which is basically just you come up with a final project that's related to STEM. And so we had the idea, because we both want to go into civil engineering, that we were going to see if there was something that the school wanted. So we went down and asked our favorite our favorite coach, Coach Pete, what he thought. So basically he wanted a larger weight room at the expense of the trainer's room, but the trainers also didn't want to lose any space. So we had multiple different people telling us they wanted things down in the weight room area. So we had multiple clients that we had to be concerned about. And so basically this is how we came up with this design project, and this is basically the final product.
And so in our class, it's just STEM engineering. It's not specifically like any type of engineering. This project happens to be civil engineering, which is both of us kind of want to go into that kind of field. So we asked around a few people and we decided on this project. One, because it kind of related closely to both of us, the weight room of our coach that we really like, and it seemed like a really fun project. And two, because it involved stuff that we were actually doing every day at work.
This is just the cover sheet giving us all the details on the project. This is the before. We spent a lot of time trying to get the proper dimensions for this.
We didn't have any plans of the actual school, so we were in the weight room with measuring tapes and everything, trying to get the dimensions and the wall thickness. It was a whole mess.
It took us 5 weeks. It was crazy because we'd go back and then we'd realize, oh no, we have to go back down and get more of the dimensions because we'd forget some, and then we'd start the Revit file, which is computer-aided design for buildings. And we'd just have to go back down and get another dimension because we'd always forget something, or something would just not line up on the CAD design, so we'd have to go back down.
So we started out just doing the weight room. We went through a few different examples. We tried to make a cheaper option than a more expensive option, just and we were still communicating with the administration of the building, trying to see what they wanted, trying to cater to their design. And so by the end of the first semester, we kind of got into a place where we felt pretty good with how it was looking. And we kind of met with them for the first time, a serious meeting, this is what we have. We went through, we kind of showed them all these different sheets of everything. And then for our second semester of the class, they kind of talked to us. They were talking about maybe doing a proposed second building, a concession stand by the new turf field Millard West had just gotten. And that kind of closely related to this. So we were yeah, we can do that. And that was a whole different experience than this, because we were starting a new building from scratch that doesn't actually exist. We were trying to dimension everything out, kind of base it off some previous buildings around different schools, and that was a pretty cool process too.
We had to also go, unlike this building, we had to rely more on the International Build Code, which is just something that the engineers around the world use for how to build the structure and how to keep things within regulatory code. So finding out the type of steel you should use, how much weight will be distributed across the roof. That stuff was stuff we'd have to take into factor. I did most of the actual design architectural work, and he did a lot more of the CAD / laying out these sheets.
A lot more the civil kind of work.
Yeah, a lot more of the civil. And basically, that was basically how it was laid out.
When doing this, the programs that we used AutoCAD, Civil 3D, and Revit. And those are two different programs that are often used by engineers. I know we both kind of have our strengths in our own programs. I'm mainly better at Civil 3D, and he's a lot better than me at Revit. So we kind of split our strengths based off what we had done at work, our actual internships, and kind of applied those skills here.
We also used a program called Bluebeam for materials estimation. It's a really new program. It's really exploding in the engineering world, but we just use that for a lot of the square footages, lengths, wall square footage, stuff like that. And that's how we got a very rough cost estimation. It's hard to get a cost estimation without having subcontractors bidding on the project, but we did the best with what we had.
So it was a really fun experience to be able to apply what we were learning in our internships to a project we chose to do at our school.
Basically, what we did with this building, went through a few iterations where before we talked to the trainers, we actually gave the weight room a lot of space. But after we talked to the trainers and they started saying, hey, we want space because we tore out a storage room here, we gave them that little winglet we added. But we also tore out these 2 storage rooms, so the weight room would get more space. The trainer's room would also get more space because they get this little expansion here. We added basically these little wings to the building right here, past this point. And
we took out a lot of walls inside of it as well to really open the area up. Just a lot of stuff specifically our coach asked for, the administration asked for.
And the trainers.
And the trainers. We kind of tried to cater to everyone and try to include them in the new building. So a lot of different redesigns happened. We probably have 4 or 5 iterations we didn't use because, put a wall back, take a wall out, make it.
Things like this with the double doors. We originally took out that double door because we already have 2 entrances, but everyone started saying we want to move equipment through there. So that we kept this double door so we could get stuff from there into the new storage room or move weight equipment in without having to completely disassemble it.
So this is the site plan we kind of came up when we were trying to design the newer building. This is the existing weight room, the school building, and this is kind of where it would be in relation to the turf field, the main street next to the school. And we were having a lot of problems for our scales and how big everything was going to be, so making the site plan was a little hard. But at the end of the day, we know this is pretty close to how it would actually look fitting in. This is all pavement that we have going together. It was a really great example to show the administration, especially, so they can kind of get an idea like, that would work. That's kind of what we want. That's where they wanted it.
A big thing that they were talking about, that deep freeze that happened in Omaha for a week that went to -10, -20. They couldn't use their 4-wheeler, which had all their salt dispersal equipment on it because it was frozen over. And basically one of the big things they talked about is they wanted a heated garage to keep it in, so that way it wouldn't freeze over like that again. I learned all of this by myself on the fly, how to put in an HVAC system in a building. And so basically, we have the actual heat, a furnace, AC unit. All of them lead into this right here that pumps heat and cool air throughout the entire building. And you have the exhaust system that pumps it through an exhaust fan in the roof. It's like those little dome things that you see on a lot of the buildings, a lot of new buildings. But yeah, that's I had to learn that off the fly.
And although technically we don't know this would exactly work because we can't run the equations, but using Revit, the software is really good, and he's pretty good with it himself, so you can kind of tell like this would be a really accurate design. It's just you can't get it stamped and approved.
And it gives you a theoretical cubic feet per minute of air movement, so I had to select proper sized, furnace didn't really give me anything, but AC and exhaust fan, that would give me a proper airflow, and that's why the pipes or the HVAC gets smaller as it goes on, because the cubic feet per minute goes down as you pump more of it out through the fans. What they specifically requested was a concession stand for the turf field because they're going to have soccer games and things like that there. This is just a utilities room with all of the HVAC equipment, water heaters, stuff like that. These 2 are basically minimum ADA spec bathrooms. ADA meaning for disabled people. They requested it to be as cheap as possible, but they also really wanted like a 2,000 square foot storage room, and this is a 2,000 square foot storage room.
So there's a lot of design challenges, restrictions we're trying to take into account as we're making all of this. It's, it took 2 semesters of school, and at the end of the day, I think we have a really nice project put together. And some of my favorite parts of it were obviously we're using skills we learn every day in our actual job sites on work, but a lot of it, there's a lot of stuff we had to learn on the fly, like he was talking about the HVAC system. Neither of us had really done any of that in our work, so just watching a lot of YouTube videos for him, getting everything put together, and so it was just really cool to use the skills we've already learned and then try to apply them to stuff we haven't learned.
Yeah.